So, hello guys, today we're going to take a look at our very own modification or our very own version of an insertion sorting array. Of course, before we get into that to our own version, we have to know first how insertion sorting works. As you can see here, I have a random array to use as an example. So basically what insertion array does, insertion sorting does, is it'll compare the values from left all the way to the right, starting from index 0. So you can see here, index 0 is 8. It's going to compare it to the value on index 1, which is 4. So there, if the value on index 0 is larger than the value on index 1, they're going to swap. And then we have index 1 to index 2, which is 8 and 2. They're going to swap. Index 2 and index 3, they're going to swap again. Index 3 and index 4, which is 8 and 3, they're going to swap. Until we reach this point where it is already sorted out. So to explain what our program does, at first, of course, it's going to check if all of the values on the array is already sorted. As you can see here, 2, 3, and 4, 2, 3, 4, and 5 are already sorted except for this one at index 4. What our program does is it's gonna compare two numbers like here from index 3 and index 4. So index 3 has a higher value than index 4, so what happens is it's gonna clone itself. So next 4 is gonna clone itself to the position of 5 here, because we already had two 5s here, so that's not gonna work. After that, these two are gonna be compared, index 1 and index 2. So the value 3 is gonna clone itself, then here the index 0 and index 1, until we reach to this point where it's already sorted. So as you can see here, when there's no more value to compare, so we have 2 here on index 0 and 2 here on index 1, what will happen is it will store the value here on index 4 previously to this index, which is index 0.
Okay guys, so this is our code and this is how we did it. On the first line, it accepts input from the user, and it, as you can see, it splits it so that we can have our very own array from that input statement. And right here we have a loop that says from 1 to the length of the array of whatever length the user wants. So we have another loop here which is from 0 to the length minus 1. So basically, if for example, if we run this code, alright, let's put an example here. We have a 4, 3, 2, 1, and 5. This is actually a length of 5, but in this loop we see that it's counting the index. It starts with 0 and its length minus 1. So basically it's 0 to 4, so it counts the index of the given array. So basically here we have the conditional statement where we have the arguments if the current counter is greater than the element beside it. So basically that's what it does, and this is our memory storage where we store the second element if needed, and then this is where we switch or we clone the two elements so that we can sort it, and this is where we stop. The very last part where we stop if there's no more comparison going on, so it means that it's already sorted. So if we go ahead and run this program, so as you can see, it does exactly how we described it. It clones itself when the argument is true, in which case 4 is greater than 3, it clones itself, and then there's no more arguments to be set there. So 3 is set. So 3 is put in index 0. Right here it clones 4 to 2, and now 2 is over here. So over here we have 4 and 1, so 4 clones itself to the position of 1, and then we have 1 iterated over here, and now it's 3 and 3. 3 cloned itself to the position of 1, and now it's 3 and 3 over here, and then over here we have 2 and 2 because 2 clones itself into the position of 3, so that's why it has 2 and 2 there now. And as we can see, it doesn't have any more comparison going on over here because it's at the very left of the array now. So what we're going to do now is that when we set this, the n equals a j plus 1, when we set that into the program's memory, we will actually iterate that certain element in this very left of the array, which is 1, and that will result us to a sorted array, which is 1 2 3 4 5.